we're going to relate what we already learned earlier this semester about these special angles. So you are writing this down in terms of degrees. This is 30 degrees, this is 45, and this is 60 degrees. Equivalent in radian measurements would be pi over 6, pi over 4, and pi over 3. Now, when we come up with the sine and cosine, a lot of students say, like, I don't remember, is it cosine first or sine first? Let me first zoom in here so you have a chance to look at the actual completed unit circle with sine and cosine. So when we're looking here, it's always CBS, cosine before sine, cosine before sine, always cosine before sine. The other thing students ask me is, like, how do I remember, like, which numbers go where? So I'm going to draw this off to the side, just up here really quickly, and this is how I know I taught you using special triangles, 45, 45, 60, and 30, 60, 90. But this is how I remember. I'm going to make a U shape here that goes around the curve, and I'm going to count 1, 2, 3, 1, 2, 3. Those numbers go in the numerator. So please do this with me. 1, 2, 3, back up. 1, 2, 3. Those are the numerators. And then mentally, I'm going to take the square root of each number. Now, if I can simplify it in my head, I'm not going to put a square root. What is the square root of 1? 1, so I don't need to put a square root. The square root of 2 and 3 are ugly. They're irrational. They're decimals that go on and on without any pattern. So we're going to put a square root over the top of the 2's and the 3's. Why not the 1's? Because the square root of 1 just simplifies down to 1. Don't have your phone out right now. Okay. Then on the bottom of each, please put down a 2. Again, we already went over what is the mathematical reason using the special triangles. But what this tells me right now, although this is done pretty ugly, what this tells me is at 30 degrees, also known at pi over 6, we have a cosine value of square root of 3 over 2, and we have a sine value of 1/2. So I'm going to come to pi over 6, which is the same as 30 degrees. Cosine is first, so in this position I'm going to write square root of 3 over 2. And in this position I'm going to write 1/2, because cosine goes first, sine goes second. I'm going to go to pi over 4, which is 45 degrees. The cosine is the square root of 2 over 2, and the sine is the square root of 2 over 2. Lastly, I'm going to go to 60 degrees, also known as pi over 3. The cosine is 1/2, and the sine is just the square root of 3 over 2. Now, as I give you a chance to write this down in a table format, can you quickly do a thumbs up or a thumbs down if this is making sense to you so far? So we're building upon what you already know. The next thing we're going to do is we're going to figure out the tangent and cotangent. Yes, there exists the reciprocal for the secondary trig functions, so cosecant and secant, yeah, they exist, but I feel confident you can take the reciprocal and figure that out. Down here, let's write tangent. You are accustomed to thinking of tangent as opposite over adjacent, and that's true. Another way to write tangent is sine over cosine. And we can write it vertically as we divide, or we may write it horizontally, sine divided by cosine. So what I'm going to do right now is I'm going to figure out the tangents and the cotangents for these 3 common angles, and that's going to make your life really, really easy for today. You need to show your work and do this with me. Let's get started with the first one. So let's figure out the tangent of pi over 6. So I'm going to write this down. I want to know, what is the tangent of pi over 6? Okay, well, I need to take the sine and divide it by the cosine. A great question that was asked me last hour, does it matter if I do sine divided by cosine or cosine divided by sine? Absolutely. Remember, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And that's exactly what you guys remembered, opposite over adjacent, right? How do we divide fractions? We keep the first number, we change division to multiplying, and we flip the second number. So I have 1/2 times 2 over the square root of 3. Now, the 2's, you may think of them as canceling out. Really, they're going to reduce down to 1's, and I'm left with 1 over the square root of 3. So at pi over 6, before I write anything down, the tangent of pi over 6 is 1 over the square root of 3. But what's wrong with that? Can anybody tell me? Yeah, it's not a proper form. Proper form says we need to throw this up top, so I have 1 square root of 3 over 3. So this is proper form. So I'm going to find the tangent of pi over 6, and then write the square root of 3 over 3. Okay, now let's figure out the cotangent. So let's go back to when it was not in proper form. And to figure out the cotangents, remember the relationship between tangent and cotangent is we just take the reciprocal. So let's go back to, we know this is mathematically right for the tangent, it just wasn't proper form. Let's flip it and we get the square root of 3 over 1. Simple enough. I want to say again, yes, there exists the reciprocal of cosecant. Yes, there exists the reciprocal of cosine, which is secant. I just didn't take time to put that into this particular table. Okay, you ready? Let's move on right now to figuring out tangent. This is the easiest one. If I said to you very easily, what's 3 divided by 3? You'd say 1. What's 10 divided by 10? 1. What's pi divided by pi? 1. When you take the same value and divide it by itself, you get 1. So when I take the tangent of pi over 4, I'm taking the square root of 2 over 2. I'm going to divide it by the square root of 2 over 2. Now, I don't even need to take time to whole stay, change, flip. When I see the same value divided by itself, I know the answer is 1. And if I flip 1, I still get 1. Now, this is kind of cool. When we do pi over 3, we're going to see if you recognize the pattern. If you recognize the pattern, you don't have to do as much work. You ready? We're now going to figure out the tangent of pi over 3, which is 60 degrees. Tangent of pi over 3. Okay, it's important I do the correct order. Sine divided by cosine. Stay, change, flip. The 2's will be eliminated. I'm left with the square root of 3 over 1. Okay, so I get to come up here and I get to write the square root of 3 over 1. I'm an opportunist. If there's an opportunity for me not to do extra work and get the right answer, I'm all about that. Does everybody see this? What's the relationship between tangent and cotangent? What do? I flip them, right? I flip them. So these two are related. They're just reciprocals. So if I got this value for the tangent of pi over 3, who can guess what I'm going to get for the cotangent without doing work? Very close. What did you say? I think you said it right. Square root of 3 over 3. Square root of 3 over 3. See this, guys? See how they're related? See how they're related? Okay, so it's time to dive into today's lesson. All of that is going to be useful. We're going to do 3 problems today. Here's the very first one, and we're going to come back to this. If you're a visual learner like I am, hopefully this will help you. Everybody start by please putting down 3 examples today. So here's example number 1. Please write down, I want to make sure that I'm not reciprocating. Let's do negative 60 degrees. Underneath it, we're going to put down the 3 major trig functions, sine, cosine, tangent, and then their reciprocals, cosecant, secant, and cotangent. Now, I'm not trying to switch up the order to mess you up. What I did not do is I did not draw attention to all-star trig class. As a reminder, this tells you when things are positive. All things are positive in quadrant 1. Only sine and its reciprocal in quadrant 2. Only tangent and its reciprocal in quadrant 3. And only cosine and its reciprocal in quadrant 4. Okay, here's the very first thing. I'm not going to call on you for an answer. I just want you to raise your hand. When you see a negative value like negative 60, what does that tell you to do? Hands up high if you know. I'm not going to call on you. Okay, about 4 or 5 of us. What it tells you to do is instead of going around this unit circle and going upwards, we're going to reverse direction and go down. So I'm going to drop down 60 degrees. So everybody make this, and we're going to drop down 60 degrees. Okay, now here's where understanding reference angles is going to make your life easy. This is a dropping down 60 degrees. I dropped down 60. And so when I look at this reference angle, the reference angle is related to the degrees it takes to move back to the x-axis, the closest x-axis. Like going here is not as close as just going back up. Going here is not as close as just going up. So I want to know which one of these 3 is exactly 60 back to the x-axis. And obviously it's right here, right? This is 30 down to the x-axis. This is 45 down. This is 60 down. So everybody come over to pi over 3, and this is where I'm going to get my values. Are you ready? This is how it's going to make life easy. So I'm going to go to sine, and I forget about positives and negatives right now. Let's just write down the value. Square root of 3 over 2. I'm going to go to cosine of pi over 3 and write 1/2. I'm going to go to tangent and write the square root of 3 over 1. I'm going to go to the cotangent and write the square root of 3 over 3. Now, how do I achieve these two? Well, they're reciprocals of these primary trig functions. I'm going to flip it, and then I'm going to flip it. Now, before we even worry about positives and negatives, I'm going to analyze. This is in simplified form. Good. There's no square root on the bottom. Simplified, no square root on the bottom, no square root on the bottom. All oh, this is not in correct form. 2 squared root of 3 over 3. We have one and only one step left. And that is to make sure that every single trig value also has the correct symbol to it. So this landed in quadrant 4. So I'm going to come back up here and go, okay, in quadrant 4, only the cosines and its reciprocals are positive. So find cosine, and we're going to put a positive for cosine and its reciprocal, and everything else gets one negative. Now, a common question I get asked is like, well, where am I supposed to put the negative? It doesn't matter as long as there's a negative. It can be on top, on the bottom, in the middle. As long as there's one negative, you've correctly evaluated the trig function. Our second example is going to be 11 pi over 4. Now, notice that pi over 4 is right here. Pi over 4 is right here. So I need to notice, where's 11 pi over 4? Here's 1 pi over 4. It's positive, so I'm moving up. So here we go. Are you ready? Here we go. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, 8 over 4, 9, 10, 11. Here's 11 pi over 4 right here in quadrant number 2. So once you locate it, then you ask yourself, okay, what is this distance back to the x-axis? Now, some students are going to be like, well, which way do you want me to go? The closest way to the x-axis. This is 45 degrees, or in radians, pi over 4. So I come back up here, and I go to pi over 4, or 45 degrees. This is going to help me. Are you ready? Here we go. Sine, square root of 2 over 2. Cosine, square root of 2 over 2. I'm following this along. Okay? Tangent 1, cotangent 1. I got all those down. Now I just need to do the cosecant and secant, and I can see where you may make a mistake in this because it needs to be in correct form and it needs to be simplified. So I'm going to slow it down. I'm going to take the reciprocal, and then I'm going to put it in correct form, which means the slow way of doing this looks like this. 2 square root of 2 over, well, this would be the square root of 4 because 2 times 2 is 4 and the square root of 4 is 2. But we still have to simplify it. Does everybody see how these 2's are in the same form? So these 2's simplify to 1, and I'm left with literally just the square root of 2. Now, if I take the square root of 2 over 2, and I take the reciprocal and it ends up with just the square root of 2, that means this also has just the square root of 2. In quadrant number 2, only sine and its reciprocal are positive. Sine is positive and its reciprocal is positive. Everything else gets one negative symbol. Everything else gets one negative symbol. While students are working on this, I'm going to share with you what I saw in a previous class as being the hardest. The hardest for students is, where do I find that? Like, once I know where it is, I can do it, but where do I find that? So my suggestion for you is always to turn the denominator, unless you're good with thirds, always turn the denominator to a 6 or 4. So whatever we multiply on the bottom by, we must multiply on the top by. So this is equivalent to negative 20 over 6. Now, some of you can do pi over 3, groups of pi over 3, and you can find it. So I'm going to reverse direction, and I'm going to go in groups of pi over 6, which is the same as 30 degrees. Okay, here we go. Ready? Here's negative 1 over 6, negative 2 over 6, negative 3, 4, 5, 6, so negative 6 over 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. That is where negative 20 pi over 6, also known as negative 10 pi over 3, lands. It's in quadrant number 2. Once you find the location, you ask yourself, okay, what's the distance down to the x-axis? And it's the closest distance, which is right here. So let's talk about degrees. What is the degrees down to the x-axis? It would be 60 degrees, which is equivalent to pi over 3. How does that help us? Okay, let's find 60 degrees over pi over 3 is right here. 60 degrees, pi over 3 is right here. So I know the sine is the square root of 3 over 2. I know the cosine is 1/2. I know the tangent is square root of 3 over 1. The cotangent, like I'm doing all of these. And now I need to take the reciprocal. So 2 over 1. 2 over the square root of 3. It's not wrong, but we got to rewrite that in better form. Okay, so I'm feeling good about all of these, and this is where a lot of students make the mistake. They're like, okay, I got it. I located the point. I know the reference angle is pi over 3 or 60 degrees. I put all the values in, and this is where they stop and they make the mistake. Who can raise their hand and tell me what mistake did they make? Go ahead, Miguel. Awesome job. So they forgot to say in quadrant 2, only the sign and its reciprocal are positive. So this is positive and positive. Everything else gets one negative placed inside.